Hi. Today we're going to be talking about the normal curve and histograms, how they go together. So if we start with our normal curve, a couple of things I wanted to point out about the normal curve is if you look at it, since this one is not skewed, it's very normal. It's centered about the mean, so our mean is in the middle, so our x bar is there. It's also symmetric. These numbers down here are going to give us our standard deviations away from the mean. So if I look at this region here that goes from 0 over to 1 up and under the curve, if I look at the stuff under there, that is going to be 34% of my data. And since this is a symmetrical relationship, if I look at this region right next to it, this one is also going to be 34% of my data. If I look out at the next region, this here is going to be 13.5%. As you can see, it's getting a little bit smaller. Most of the data, 68% of the data, is in between that first set. This little tiny region right here is 2.35%, and then that's almost everything. Just outside that, we have 0.15%. And of course, we said that this is symmetrical. So over here, I have another 13.5%. Over here, I have another 2.35%. And then outside here, I'll have another 0.15%. So it goes up and down. So I've continued the lines here for those standard deviations away. So I wanted to talk about, well, let's look at here from the mean. If I go one standard deviation bigger, one standard deviation smaller, that's within one standard deviation. And if I look at those two numbers, those two things are going to add up to 68% of all of my data has to be within one standard deviation of the mean if I go bigger or smaller. If I look here, if I go, hey, let's go out 2 standard deviations for the mean, right? So I'm looking at all of this data, right? So you can see I'm going from there to there. I've got all of that data captured. So I'll have the 68% that's in the middle, but then I add this 13.5 and this 13.5. I add that all up, and I'm going to get 95% of my data is going to be right here in the middle. And there are some out there, some normal curves that are a little bit more precise with their numbers. So let me point out that these are going to, these are approximately 34%, approximately 13.5%, 2.35 and 0.15. You'll see some different numbers out there occasionally. These are just the most common that we use. Okay, and then within 3 standard deviations of the mean, right? If I go all the way out to there, and I add all these up, I got everything except for this little guy and this little guy here, which are 0.3 if I add them together. So that means that this is going to be 99.7%. Almost all of my data was in 3 standard deviations of the mean. Okay, and that's what a normal curve looks like, and some properties of a normal curve. Now, of course, we don't have to limit it to just going the same number in each direction. I could say, hey, what if I had this? Like, let's give me all of the data that's going to be smaller than the mean. And if you think about it just from a logical standpoint, the mean is going to be right there in the middle, so this is going to give me 50% of my data. If I add up 34, 13.5, 2.35, and 0.15, I'll get 50. I can do something like, well, hey, let's look at everything bigger than what that one standard deviation is there. Well, this one's pretty similar than going the other direction, except for I've got half of it going above and only one below. But if I add those two together, I'll get my 50% above and 34% below. So we'd say that they're 84%. And I can break those down between any of those standard deviations pretty much any way you want to and add them up, and I'll get the percentage. And then when I have something like, well, what about here? What if I have 1.5? Well, then I gotta say that's what we're gonna look for our z-values for, right? If we have something like that, we're gonna look at the z-value for that, and it's gonna show us the percentage that goes below that. And we can tell, hey, you know what? I know it's gonna be in between there. I know everything to the left of this is going to give me 84%. So, you know, you can have a way to sort of self-check whether or not you've used your z-table correctly, because you know the number should be bigger than 84%. So then we can ask ourselves, well, what can we use this for? And I'm gonna say, hey, let's look at a set of data that we might have, and we've got a histogram for it. We can look at what our normal curves look like in comparison to a histogram. And I have the question, which one appears to be more normal? So if we look at it, this guy here looks a lot closer to that normal curve than this guy does, with the fact that he's under here and here and here. And so what we can do is say, hey, this one looks a lot more normal. I think that if we're using our normal curve, those empirical values that we had up here, to predict information about this data, I got a lot more confidence in this guy than I do the other one. And so we're going to use an example in our book, and we're going to create and put all of this together and then compare our data to a normal curve and see what kind of information we can get from it. So what I have here is problem 6.1-4, and it is a sample of the melting points of an alloy for a company. There's an array of 10 by 5, so we have 50 data points that we're looking at. It's worth mentioning that that's a sample, so when we try and find our values here, our sample mean, our sample standard deviation, our x bar is going to be our mean, our s is going to be our sample standard deviation. If you look, part A asks us to construct a frequency distribution and display the histogram. So I started by making a frequency table. You can see here I've got 305 is my lowest value. I've only got one of those. 335 is my biggest value. I've only got one of those. I can find the range of these values. If I wanted to set up an interval class and do it that way, I could, but we've just got all of the values here. I constructed the histogram just based on the frequency, and this is what it looked like. So we know that our mean is the summation of everything divided by the number of values. So when I went ahead and did this out ahead of time before, and I've got my mean is 320.1, and then my S value, my standard deviation, is 6.75. Okay, so I'm going to go ahead and let's move these down here. So for part B, I have x bar equals 320.1. Standard deviation is 6.75. And it says locate your mean plus s, mean plus 2s. So that's one standard deviation away, bigger and smaller. Two standard deviations away, bigger and smaller. And then it asks us how many observations lie within one standard deviation, how many lie within two standard deviations. So let's go ahead and find those values. So I'm going to start with x bar plus or minus one standard deviation away. So it's going to give me this interval here. I have 320.1 minus 6.75 for my standard deviation. And I've got 320.1 plus 6.75, which is one standard deviation bigger. And I get the values 313.35 all the way to 326.85. So that's one standard deviation away from the mean. I'm going to go ahead and do two standard deviations away. So here's 320.1, minus 2 times 6.75, and then 320.1 plus 2 times 6.75. Okay, and those values are going to be 306.6 all the way to 333.6. Okay, so I've got those values. I'm going to go ahead and put them on this particular histogram. I went ahead and did that out already. So I've got, excuse me, what looks like my red bars here represent my standard deviations away from the mean. And as we know from our empirical data, I know that this one should be somewhere around 68%. And then this here should be somewhere around 95%. Okay. So what I did then was I counted up all of these bars that I have in between here and here, right? So I get 2. And if I did 1 standard deviation below and 1 standard deviation above, what I got was 33 data points. All right, so if we look at 33 out of my 50 data points, that's equal to 66%, which is, I'm going to say that this is, I'm going to give it a green check mark because that's pretty darn close. And then if I count up all of the information for all of the points that are within 2 standard deviations away, I got 48 out of my 50, which of course is going to give me 96%. And that's really pretty darn close. So this one appears normal, it distributes like normal, and we've answered all of the questions. So if you have any questions, please let me know. Hope you enjoyed the lesson.